Okay, good morning. I wanted to do a brief tutorial video for those of you that missed our Zoom either Tuesday or Wednesday on our Chapter 10 test review, which goes over the sections 10.1, 10.2, 10.6, and 10.7. All of that material can be found in the virtual learning folders 4, 5, and 6. All right, so I'm not going to go over the very basic problems. For instance, area of a parallelogram, I'm not going to go over. Area of a triangle, I'm not going to go over. That's all very basic problems. If you need the formulas for those, I posted the Chapter 10 test formula sheet. I also emailed it out to everybody Tuesday morning, where you have the formulas for area of a triangle, area of a rectangle, a parallelogram, area of a trapezoid I will cover, area of a rhombus I will cover very briefly. I'll start off with this problem, which is just a very basic. If I'm given the area of a parallelogram and the height, how do I find the base? So the area formula for a parallelogram is area equals base times height. So in this problem, they didn't give you base and height. They gave you the area of a parallelogram is 15 feet squared. So that 15 represents the A for area, and the height is 3. Find the length of the corresponding base. So in this problem, you're doing 15 equals b times 3. And to solve for the base, you just divide by 3. B is equal to 5 in this problem. Okay, find the area of parallelogram ADKF. So in this problem, I want to find the area of parallelogram ADKF. So to do that, I just have to find its base and its height. So I'm just going to count across from A to D to find the length of the base. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the base is 9. And the height is any distance where it connects the two bases, or the top and the bottom, in a straight line and forms a right angle. 1, 2, 3. That has a height of 3. So in this problem, area is equal to my base 9 times my height 3, which is a very basic 27. Okay, in this problem, they want us to graph these 3 lines and then find the area of the triangle that is formed. So the first one they want me to graph is the line x plus 2. So I go over here to my line tool, and the first thing I'm going to graph is y equals x plus 2, which tells me I have a y-intercept at positive 2. So I go up to my y to positive 2, and my slope is 1x, so it's just rise over a run of 1 over 1. So I rise 1 over 1, rise 1 over 1, rise 1 over 1. Doesn't matter how many times you do it. You can just do it the one time. I'm going to go rise up, go over 1, plot the point, and there's the line y equals x plus 2. Then I need to do the line of y equals 2, which is a horizontal line where y is 2. So here's the line y equals 2. And then lastly, they want me to do the line x equals 8. So I'm going to graph a vertical line where my x value is 8. And lo and behold, I get a triangle. So then the second part of the question, so you'll save that. And then the second part of the question is it wants you to solve for the area of this triangle. And the area formula for a triangle is 1/2 base times height. So I'll just look for the base, which goes from 0 to 8. So it must be 8. And the height goes up 1, 2, 3, 4, 5, 6, 7, 8 as well. So this is your base. This is your height. Plug those into the area of a triangle formula, and you'll be good to go. Okay, find the area of this figure. So this is a composite figure. So when you have these composite problems, what you want to do is break them down into shapes that we know the formulas for. So for instance, this shape can break down into a rectangle, a red rectangle right here, and then a blue triangle. Okay, so now they gave us a bunch of different measurements we're going to use to solve. So we have to find the area of the rectangle first. And a rectangle's area is just simply length times width. So in this problem, my length is 160, my width is 30. So that's easy. But what we do have to do is we have to add this to the area of the triangle to get the total area. So now this blue part of the triangle is not 140. I need to find this, which is the height. And what they gave me is that this distance from here to here is 140. So what I have to do is I have to break this down. So I know that from here to here, if I look across my rectangle, is 30. So this height of the triangle, so my height, h, is going to be 140 minus that 30 piece, which is going to be 110. And then the base of my triangle, let's say, is going to be from here to here. This is the base of the triangle. And again, you kind of have to turn your head a little bit, and you'll see that this part of this line is 160, and this makes up 80 of that 160. This is obviously not drawn to scale at all. So the base is equal to 160 minus 80, which is 80. So then I plug this into my formula for area of a triangle, which is 1/2 times base times height. So it's 1/2 times 110 times 80. And when you put this into a calculator individually, you'll get 160 times 30 is 4,800 plus 1/2 or 0.5 times 110 times 80 is 4,400. And when you add those two numbers together, I get 9,200 as an answer. Okay, area is a trapezoid. I'm only going to do one of these problems. Area of a trapezoid has the following formula: 1/2 times its height, which runs up and down the middle, times base 1 plus base 2. So I'm just going to identify, I'm not actually going to solve this. So the formula is area equals 1/2 times the height times the sum of base 1 plus base 2. So trapezoid has two bases. I'll call this 6 base 1. I'll call this 10 base 2. It does not matter what you call base 1 and base 2. And the 5 is the height. So when you plug this in, it's just 1/2 times 5 times 6 plus 10. Follow your order of operations. 6 plus 10 is 16. And then you solve this out and you'd get 40. Okay, area of a rhombus or a kite. Again, you go back to your formula sheet. You'll find that area is equal to 1/2 of diagonal 1 times diagonal 2. So what are my diagonals? So one diagonal is the distance from this point to this point, and my other diagonal is the distance from this point to this point. So now notice that the diagonals are broken up into two equal pieces. So this is 24 over here. So this is 24. So one of my diagonals, the red diagonal, is 24 plus 24. And my blue diagonal is going to be 18 plus 18, because that piece is going to be 18 as well. So then the formula becomes 1/2 times 48 times 36. You plug that into a calculator and solve on your own. That's another trapezoid problem. Okay, this trapezoid problem is a little bit more difficult because there's an extra step to it. So what I'm going to do is I'm just going to redraw it so that we can see it in a different way, because it's easier to see this problem when you look at it like this. So obviously it's a little bigger. It doesn't make sense. So the values here are, we've been given 17 on, nope, we've been given 30 on top, 17 as a hypotenuse, 15 as part of the base. And what we need to solve this is we need base 1 for a trapezoid. Base 2 is all of this down here. So I know that from here to here is 30. So this is also 30 down here. So my base 1 is 30, but my base 2 is 30 plus 15, which is 45. And the last piece that we need is the height of the trapezoid to be able to find its area. Now, I haven't been given the height, but what I have been given is a right triangle. So how do we solve for missing sides of a right triangle? We use the Pythagorean theorem. A squared plus b squared equals c squared. So then in this problem, I get h squared, which is my height, plus my b is 15, equals 17 squared. Then when I square these things, 15 squared is 225, 17 squared is 289. I'm running out of room, but you subtract 225 from 289, and you get 64. Take the square root, h equals 8. So now you have all the pieces you need to solve for the area of a trapezoid. My base 1 is 30. My base 2 is 45. My height is 8. And then you'll plug all of this into the formula for the area of a trapezoid, and that's how you get your answer. Okay, I just need to close out of MathXL for some reason and start this process over. Did that. Okay, circumference I'm not covering. Did that problem a million times. I've done this problem a million times. If you still need help, find time to email me. Arc length shown. Again, to solve for arc length, you use the formula for arc length, which is on our formula sheet. Arc length is equal to 2 times pi times the radius times whatever the measure of your arc is in degrees divided by 360. So the hardest part about this problem is, what is the measure of this arc in degrees? So just be mindful that this piece of my arc is 60. These two arcs together create a semicircle, which is 180 degrees. So that makes your x degrees 120. And be careful that this 66 here is not a radius, it's a diameter. So my radius is 66 divided by 2, which is 33. If you don't know the difference between a radius and diameter, please look that up. Okay, in this problem, this is a basic, all of these arcs make up the entire circle. So from R to P represents x plus 30, while P to Q represents 3x plus 60, while Q to R represents 4x plus 30. So then all you have to do is know that all of these arcs in the circle add up to 360 degrees. So then this problem just becomes x plus 30 plus 3x plus 60 plus 4x plus 30. And that's how you solve. And then you combine like terms, you solve for x. Okay, I'll do a sector area problem very quickly. Find the area of the sector. This is very similar to arc length, except it now uses the area of a circle. So sector area is equal to pi times radius squared times your x over your arc measure divided by 360. So this problem becomes very basic. Pi times my radius is 9. My arc measure is 80 divided by 360. Now it wants your answer in terms of pi. So what you have to do is you have to multiply all these numbers first. This is how you'd put it in your calculator, and then you'd slap pi on at the end. The other thing I recommend you use is the Desmos Scientific Calculator, which can be found by either downloading the app on your phone, Desmos Scientific Calculator, or opening it up in your browser. Again, you go to desmos.com/scientific. And then if I plug this in, 9 squared times 80 divided by 360. Oopsie. Go back. Divided by 360. I get an answer of 18. And then I just slap a pi at the end of it. So your answer, when you plug this in to the problem, is 18. And then you put a pi symbol next to it. Area of a circle is very basic. Just be careful how you find the shaded region here. Okay, this is a diameter, so make sure you find the radius first. And know that this yellow piece plus this black arc have to add up to 180. So that's how you solve for your x degrees. So in this problem, my radius is 13. The measure of my yellow piece in degrees is 30, because 30 plus 150 adds up to 180. You plug into the area of a sector formula and solve. Again, be careful. This is a radius. This whole yellow piece is going to be 360 minus 90. That one, they just give you the answer. And this last problem, they're telling you what is the sector area. So my sector area is 98 pi. And they want us to solve for the radius. So then when I plug this into the formula, I've been given all of this information. So to solve this, the pi's cancel out, and I'm left with 98 equals radius squared times 45 divided by 360. we need to isolate the radius. So to cancel out the 45 over 360, you multiply the inverse. That's a basic algebra fact. So that these cancel out. And when I find out what 360 divided by 45 times 98, 8 times 98 is 784. So this becomes 784 equals radius squared. And then to solve for the radius, you just take the square root of whatever this number is, and the square root of 784 is 28. So my radius is 28.